So today we are going to learn about machine learning. So before beginning classification chapter, which is very important in the domain of data science, machine learning, or big data analytics. So it is very vital that you should be aware about the basic machine learning concepts. So what is machine learning? So machine learning is actually considered as a science or an art uh, where you actually program the computers so that the computers will automatically learn the data, and anything you will provide an input in an input format to the computer. So actually the input format are again of different types. So in various formats it can take the inputs, then it can process the data or analyze the data using any machine learning model, and then it will give you the output in the format in which that you need. And most of the time, so machine learning techniques or the model, they actually analyze or get into the depth of a large amount or vast amount of data. And from there, you can discover a various number of patterns, and which are not always really efficient to handle or to explore different meaningful data, information from them. So machine learning is actually is a concept that a computer program basically can learn and adapt to new data without human intervention. You don't have to interfere with the process. You just have to input the data to the model. And again, for choosing the model, you need to follow certain guidelines. And there are different models meant for different types of data. We are going to look into them. And machine learning is a field of artificial intelligence or AI. You must have heard about it. Okay. And this keeps computers' built in algorithms current regardless of changes in the worldwide economy. So, mm, now to mostly summarize why the machine learning is really useful. So actually why it's useful? So because it is used mostly in internet search engines, email filters to sort out the spam emails, okay, which are the meaningful emails or important emails, and which are not. Which are not, they go to the spam filter or the spam section. And various websites to make personalized recommendations, then banking software to detect unusual transactions, and a lot of applications on our phones, such as voice recognition or speech recognition technology. So actually problems for which existing solutions require a lot of human effort, and which requires a long set of rules. Okay, so often what happens, the machine learning algorithms or models are really helpful to simplify those complex rules, or simplify the code, and give us a efficient performance or better performance. So mostly whenever the problems are too complex to handle, which is not easier for the human being to interact with, so in that case, um, so rather than using this traditional approach, you can use the machine learning models. So in case of fluctuating environments also, it is really useful. So machine learning systems are really adaptable to new set of data. So let's say you have fed the data or inputted the data to a particular machine learning model. Now let's say you got some meaningful patterns, some meaningful information from them. Suppose a new set of data comes which is similar to the previous data, not exactly same, but in that case also our model which is tuned for that previous similar type of data, it will be also be able to handle the new set of similar type of data. So mostly useful, it is machine learning models are mostly useful for getting insights about various complex problems or a very large data set. So these are some of the applications. And initially also I have gave you some of the examples of website recommendations or spam email filtration or tracking of unusual transactions in the banking software or speech recognition. So in all such type of technology, your machine learning models are really helpful. So let's see what is traditional approach. So what is the traditional approach actually without using the machine learning models? So traditional programming usually refers to manually created program that uses input data and runs on a computer to produce the output. It's a basic traditional programming. But in machine learning, it is also called as augmented analytics, where the input data and output are fed to an algorithm to create a program explicitly. You both provide the input and the output, and based on the tuning of your machine learning algorithm or model, you will be able to find meaningful information. So this type of machine learning algorithms, they actually learn from the data where choice of algorithm and inputs. Uh, in that case, they are also called as features. Okay, features of data. So these are to be inputted to algorithm. These are made by the subject matter experts, which are actually, so there are different types of domain. So some people uh, work with the environment or the weather data. So some people work with something else with the software data. So it depends on what type of domain it is and what type of expertise is needed. And traditional machine learning models actually expects inputs to in the format of structured data like numbers. So whenever you are studying a problem, okay, you would have to write a defined set of rules for it. Then you have to evaluate it. If it is perfect as per your need, then you can directly launch it. If you get some errors, then again you have to reanalyze it and again study and reiterate the same thing again and again. Now comes your machine learning approach. Actually, what happens here in the machine learning approach, you have the data, okay, data as input, and data can be of different forms. It can be a different format of data and different domain of data for which domain expertise is needed. That data is fed to the machine learning algorithm mostly. So algorithm is there, okay, and you feed the data. But in that case, you need to also study the problem and the let's say you have the algorithm or the model and you just inputted some data, but it isn't certain that you will get a defined output. Maybe the output that you are getting, it is not as per your expectation or not something that you want. Then in that case, what you need to do, you need to evaluate the solution whether it is matching your defined criterias. You are getting the output that you are getting, whether it is as per your need, expectation or not, that you need to decide. And then you will be able to finalize that yes, this is your solution. But let's say you have fed the data after studying the problem to the model, but let's say the output is not matching actually. You are getting some um, irrelevant outputs which doesn't have any meaning to your own analysis. So in that case, what you need to do, now again you have to analyze and fine tune the model or the data. Maybe you have to change something in the data, or maybe you have to tune some parameters in your machine learning model. So there are different things you have to take into action in that case. Okay. So traditionally, the software engineering combined human created rules with data to create answers to a problem. So instead, machine learning actually uses the data and answers to discover the rules behind a problem. To learn the rules governing a phenomenon, the machines actually have to go through a learning process mostly that I was just explaining to you, and they actually try different types of rules and learning from how well they can perform. and that is why it is called machine learning. The machine need to learn until it gives us a correct output as per our requirement. Then how the machine learning algorithms actually help the humans learn. So there will be data and it will be imported to the algorithm. Basically imported means you need to train the data. So suppose you have this set of data, and let's say after evaluating this data through the model, you got some solution, you kept it there, okay, it is there. But let's say some different type of data comes to picture, and in that case that particular algorithm or model that you have used in the previous scenario will also might be helpful in this case. Suppose you decide that, okay. So in that case what you need to do, in that case you need to train your algorithm in such a way that it should work for different varieties, structures or features of data, okay. So there are, in that case, so suppose you are training the machine learning algorithm. Let me give you an example. Suppose you have 100, you have a you have a data set where there are 100 elements or samples. So first you may keep some of the data elements, let's say 20 out of 100 as a test data set, and you keep the rest, that is 80 out of 100 as a training data set. So the 80 will be fed through the machine learning algorithm and you train the model. So after you train the model, the training format of the data will give you some sort of solution, and you will inspect the solution whether that problem is performing well or not. If needed, you need to reiterate it. So again, when you have a 20 samples which is left out of your 100 for testing purpose, now you can test the algorithm using that test data feeding to your same model. So this is actually the difference between training and testing. In order a machine learning algorithm to work or perform better or correctly, you need to first train it, tune it, okay. So again, there are various forms of machine learning. So machine learning is not just simple machine learning. There are different types of data, and in order to handle different types of data, you need different types of learning or models. So what are those learnings? They are supervised, unsupervised, semi-supervised, and reinforcement learning. Here in this slide, you will get those details. So again, each form of the machine learning has different types of approaches. So all these types: supervised, unsupervised, semi-supervised, reinforcement, online versus batch learning, instance-based, model-based. There are various types of learning. So these are different approaches, but they actually all follow the same process and theory as well. And this explanation, it covers the general machine learning concept, and then it focuses on each approach individually. So let's see our different types of approaches here. First, let's see our supervised. So suppose while categorizing these four types, so you need to see whether or not they are trained with human supervision or not, whether human interference or supervision is needed or not. So in terms of that, supervised learning is the process of an algorithm learning from the training data set, which can be thought of as a teacher supervising the learning process. There is a teacher or a supervisor kind of person who will be supervising the thing. And we know the correct answers in that case, and the algorithm will repeatedly make predictions on the training data. Initially, what you need, what data you give for training purpose, and then it is corrected by the supervisor or the teacher, which is assigned for this particular supervised learning. Then learning will stop when the algorithm will achieve an acceptable level of performance. So this is what your supervised learning is. Let's move on to the unsupervised. So unlike the supervised learning, in the supervised learning type, here in unsupervised type, there is no correct answers, no correct outputs, and there is no teacher or no supervisor. The algorithms are left to their own devices to discover and present the interesting structure in the data. This is your unsupervised type. Then comes your reinforcement learning. Reinforcement means there is some sort of reward system associated with the reinforcement. So this is the easy way to remember. Reward associated with reinforcement. So what is that? So this is a training of machine learning model to make a sequence of decision. So there is an agent. There should be an agent in reinforcement learning. That agent will learn to achieve a goal in an uncertain or potentially complex environment. Okay. And in this case, an AI or artificial intelligence faces a game like situation, and its goal is to maximize the total reward. I'm going to show you one example towards the end of our this PPT associated with the reinforcement learning. Then comes our online versus batch learning. So whether or not they can learn incrementally on a fly. So what does it mean? So online is basically learning based on each pattern as it is observed. While you are learning, more data items will be flying to the system as input, and automatically or sequentially they will be learned. And in the batch, here in the batch system, you learn over group of patterns. You need to learn in patterns or group in the basing of groups, which is unlike the in your online learning system. The next is your instance based system. So instance based, model based. First we will see the instance based. So here what is this? So you need to see whether the work by simply comparing the new data points to the no data points, and instead it will detect the patterns in training data and build a predictive model. So what does it mean? So sometimes we have a type of learning called memory based learning. So it is a family of learning algorithm that instead of performing explicit generalization, it compares new problem instance with instances seen in the training. Okay, and which have been stored in the memory. So this is kind of complex. We are going to see some of the example machine learning model, that is k nearest neighbor and decision tree, in the future courses, which is related to this type of machine learning. Then comes your model based learning. So model based learning is actually, this is actually your machine learning model, which is parameterized with a certain number of parameters that do not change as the size of training data changes. So if you don't assume any distribution with a fixed number of parameters over your data. So for example, gave you the example, those models we are going to cover, k nearest neighbor and decision tree, where our number of parameter will grow in size of the training data, and then you are not model based or non-parameter. So this is some basics about the types of machine learning that we have. So first, the important type is our supervised learning. So here see some of the algorithms have been, or method approaches have been listed. KNN, K nearest neighbor, regression model, support vector machine is important, decision tree and neural network. So in the future classes, we are going to learn about all this. These are like separate chapters each. So as I told you, what type of learning it is a supervised. So supervised is the process of algorithm learning from a training data set, which can be thought of as a teacher supervising the learning process. Okay, here we actually know the correct answer, and algorithm iteratively makes predictions on the training data and is corrected by the supervisor or the teacher. And when the learning will stop, it will stop when algorithm achieves an acceptable level of performance. So here it's a picture showing the labeling of the training data set. So what does it mean? Actually, you have a data set with different data points, and they have their own labels associated with them. So these red signs, these are with a different level. The green signs are with a different level. So you have trained your model like this, that each of the labels, so these three green types have a certain level associated with them, so they are classified as similar type of data. Suppose these three are your good emails or your necessary emails which should come to your inbox, and let's say the red sign ones, these are the spam, which are unnecessary, unimportant um, emails, right? So likewise they are classified, but how they will be classified, how they will be labeled, there will be some sort of features or characteristics associated with it. How do you distinguish between a cat and dog? There are some differences in between their characteristics and features, right? So this is the same way. So if you have trained your model in this way, the whenever a new instance will come without a label, so how do you classify that, which type of data or label it will belong to, whether the green one or red one? Okay, so this is your supervised learning. Your input will be there, also your required output characteristics will be there. So from that, the new instance will be classified either as the green type sign or the red type sign. Mm. Next comes regression. So regression is really very vital in your classification machine learning. Uh, so actually this type of model, it actually deals with a special type of data. So what type of data it is? So these regression models are used to predict continuous values. So I can give you an example. So let's say you want to predict the prices of a house given the features of house like size, price, etc. is one of the common examples of regression, and it is also a supervised technique. So regression analysis is a way to find trends in the data. So for example, you might guess that there is a connection between how much you eat and how much you weigh. So regression analysis can help you to quantify that. So it can provide you, the regression analysis will provide you with an equation for a graph so that you can make predictions about your data. So an example can be, if you have been putting on weight over last few years, let's say 5 or 4 or 2 years, so it can predict, this regression analysis process, it is able to predict how much you will weigh in next 10 years time if you continue to put on weight at the same rate. Okay, and it will also give you um, a format of statistics kind of value. So that statistic will be in the form of p-value or correlation coefficient. You don't know about them, and these are some certain concepts associated with machine learning. P-value, correlation coefficient, and these will help you um, to tell that how accurate your model is. The p-value correlation efficient will give you um, a overlook of how your model is performing actually. So most elementary statistics courses cover very basic techniques like making scatter plots or performing linear regressions. This is a kind of plot from which you will just plot it, and from there you will say that your model that that you have you going to use, or you will be using in future, it will be a proper model for your data or not. So that was all about supervised. Next, we are moving on to unsupervised. So within the field of machine learning, there are two main type of tasks that you know, supervised, unsupervised. So what is the main difference? As I just explained, the main difference between the two types is that supervised learning is done with a ground truth where you know the input and output. In other words, if I want to put in, so we should have a prior knowledge of what the output values for our samples should be. So therefore, the goal of supervised learning is to learn a function given that a sample of data and desired outputs. The best approximates the relationship between input and output of the data. But just the reverse or the alternate is your unsupervised learning. So which does not have any labeled outputs. And so here the goal is to infer the natural structure present within a set of data points. So let's take an example. Okay, let me note it. So let's take the case of a baby is there, okay, and a dog is there, okay. So baby and dog. So actually the baby can identify the dog, or a person can identify the dog. So few weeks later, a family friend will bring along a dog and will try to play with the baby, right? So baby has not seen this dog earlier, the other dog that comes. That baby has not seen this dog earlier, but it recognizes many features. What are those features? Looking into number of ears, eyes, 2 ears, eyes, walking on 4 legs, are like her pet dog. So here she will identify the new animal as a dog. So this is a case of a unsupervised learning where you are not taught, but you learn from the data, in this case the data about a dog. So if this had been a supervised learning, the family friend would have told the baby that this is actually it's a dog. So this is the main difference between your supervised and unsupervised learning. Here some of the methodologies that we have covered earlier, or we are going to cover in future as well. Okay, so K-means we are going to cover, hierarchical clustering. So these are actually, we have covered K-means. So clustering algorithms, these are the algorithms methods that we have already seen them. So visualization and dimensionality reduction, we have not seen this, but it is actually important in the case of machine learning. And for association rule learning, so we have already seen the approaches, that is a priori and FP tree, which is also used for our unsupervised learning. Then we saw the supervised, unsupervised. Let's see semi-supervised. Okay. So suppose in your training data set, all the training data set are not properly labeled. Some of them are still remaining to be labeled. So for dealing with the partially labeled training data, so usually a lot of unlabeled data and a little bit of labeled data will be there. And this type of learning is called your semi-supervised learning. So semi-supervised machine learning is actually a combination of supervised and unsupervised learning. And it uses a small amount of labeled data and a large amount of unlabeled data. So unlabeled means you don't have any knowledge about those data. And this will provide the benefits of both unsupervised and supervised learning while avoiding the challenges of finding a large amount of labeled data. So suppose you have a big data set, but let's say there are 1,000 data points, but let's say all the data are not labeled, right? At certain times, there may be certain instances where the data will not be labeled, or those data will be unknown to the whole system or to anyone. In that case, how to handle that situation? So in this situation, semi-supervised comes to picture. So in this case, how do you train the model? So you can train the model to label the data without having to use as much labeled training data. So there are some practical applications of semi-supervised learning. Speech analysis, first one. So since labeling of audio files is a very intensive task, the semi-supervised learning is a very natural approach to solve the problem. Okay, or let's say internet content classification. So labeling each web page is an impractical and unfeasible process, correct? So in that case, this type of learning is useful. Even in the Google search algorithm, it uses a variant, some type of variant of this type of semi-supervised learning to rank the relevance of web page for a given query. Or let's take the protein sequence classification or DNA sequence classification. So as DNA information are typically very large in size, so this supervised learning is actually eminent in the protein or DNA classification applications as well. And in this case also, one advantage is that one disadvantage and advantage in both types. Advantage is that if you have some unlabeled data, those are not labeled at all, it is easier to handle in this type of learning and you don't have to label all the data. Then comes your reinforcement learning. So if you see the picture, you can maximize it and see this picture. I think I should have added a link actually. Give me a moment. I can open it here. It is a really useful report. Say this picture is here, okay? The reinforcement learning. So as I told you, reinforcement learning is associated with the reward system. You can take a note of it and Maruti Tech Labs. And you can read the whole example. So what it's trying to say, in reinforcement learning, a certain type of reward system is there. And suppose there is an agent. Here you have fire and here you have a tap where the water is flowing and there is a bucket. So in that case, what the agent is supposed to be relatively doing? Should the agent pick the fire or the bucket? So in this case, the bucket is needed for this requirement. So suppose by mistake, first the agent absorbed, then it selected the action using the policy. Okay, suppose the agent picked the fire, so which is wrong. Okay, so in that case it lost minus 50 points, it lost 50 points. So there should be some sort of reward or penalty system so that the agent will be aware that as I got negative points, that means something wrong I did. I need to go through a different way. Okay. So now the policy is updated or the learning step is updated, and next time it will decide what the agent is supposed to do, whether to choose the left or the right. So this type of learning is called your reinforcement learning. So it is the training of machine learning models to make a sequence of decisions mostly, and the agent learns to achieve a goal in an uncertain, potentially complex environment. In reinforcement learning, an artificial intelligence faces a game like situation, and its goal is to maximize the total reward. Okay. Okay, now this is our last slide. It's about the batch or online learning. So online, as I already explained before in the initial slides, so learning based on each pattern as it is observed, while batch, the learning is actually done in the format of groups of patterns. So batch in the online learning, first you train the system incrementally by feeding its data instances sequentially, either individually or by a small group called mini batches. And each learning step is fast and cheap so that the system can learn about new data on the fly. So see here, the data is just continuously flowing to the system as it arrives, and data on the system can learn about new data on the fly as it arrives, as it's shown in the picture. And online learning is great for systems that receive data as a continuous flow. So let's take the example of stock prices. Okay, stock prices data, it's something which never ends. So data is just flowing in, and you are just training your model and getting required output from there. So here in this type of situation, you need to adapt to the change rapidly or autonomously. So it is also a good option if you have limited computing resources. Suppose once an online learning system has learned about new data instances, so it doesn't need them anymore. So you can discard them unless you want to be able to roll back to a previous state and replay the data. And this can save a huge amount of space. And your batch learning is actually the system is incapable of learning incrementally. It must be trained using all available data. And this will generally take a lot of time and computing resources. So, mostly the batch learning is often done offline. So, first the system is mostly trained and then it is launched to production. It is it will go to production and runs without learning anymore, and it just applies what it has learned. So this is called offline learning. So today's session was mostly about the machine learning fundamentals. So once you got some idea about different types of learning, whether it may be supervised, unsupervised, semi supervised, reinforcement. Okay, so once you have those concepts, now we can dive into further the machine learning models, such as your in this slide. Let me show you the k-nearest neighbor, support vector machine, decision tree, regression. So this will be easier to capture. Okay, so that's all for today's lecture. If you have any questions, please let me know.